I think the phrase the SAT gives us useless information or extra information is a relative term. I think really what it's important to understand is they typically don't give us numbers that we won't use. Any number that they give us is helpful. In a word problem like this, a lot of the description's pretty useless, especially when you get used to the pattern of the SAT and we see that they give us this equation here and all of our answers have f by itself. What they're asking us is, can we make this equation look like this equation? Can you get f by itself where there's only one f? And this one's particularly tricky because there's two f's. Usually when they ask us to do that, maybe there's one f and all you got to do is throw stuff on the other side. This case, we're going to have to get a little creative with our factoring. Because it's also it's a question of which of the following expresses the number of favorable views to the other variables. Or essentially which one of these is like which one of this is the proper rearrangement of the top one. What you can technically do, and we won't do it here because it's not the fastest answer, is come up with your own values for f, n, and r. If you're doing this method, let's say that you want to pick simple numbers 4, -2, and 2. The reason I chose this is because I wanted the denominator, maybe we'll go through it, n plus f, because I wanted the denominator to be a positive even number because it's the no calculator section, and I wanted to make sure that I was dividing by an even number, or by 2, because it's really the easiest thing to divide by. And then the top would be 4. So what I knew is that we would end up with, so if we were to rewrite this, r equals f, so that means like 4 over -2 plus 4. And then and so we actually wouldn't know what r is at this point. And then once I saw for it, r would be 2 because 4 divided by this would eventually become 2. 4 divided by 2 is 2. So that the question is, like, if I were to plug in for these same numbers, which one would give me 4? If I plugged in -2 for n, and I put r for r, and I said 2 equals r, which one here would give me 4 equaling f? And there's only one, and that would be b. Now, how can we go about factoring this the way that maybe we should? Because if we get good at it, it's going to help us in a lot more problems. Now, if you were, by the way, going to plug in like this, I recommend you skip it and come back because it is not the most efficient use of your time. But it would be if you came back to it. And let's see how we can do this. So we know that we have to get f by itself. So r equals f over n plus f. First thing first, we see a fraction. Let's get rid of that thing. Let's make this one straight line. So we multiply both sides by that, n plus f, and then you have n plus f out here. And do we want to distribute that r? So this is the reason. Do we want to distribute this r here and do that? Well, remember, I want to get f by itself. So the question is, can I get f somehow away to this side without having to distribute? And the answer is no, and that's why we know we want to distribute. So this now becomes Rn plus Rf equals f. Okay, nice. Now, what we can do is get so what we can do is now we can try and get our f's back to one side here, now that it's going to be linear. Because remember, yes, they were the same side here on top, but they were in a fraction. But now that it's all going to be linear, it's easier to work with. So we have our Rn would equal f minus Rf. Now this is where it gets a little tricky because it's weird here because we're factoring out, we're going to factor out f. It'd be nice if we can just get one f now on the board. And the way we do that is we factor it out. So we end up with f. And we have to ask ourselves, well, if we're replacing these two terms here, what's going to be in its place now that we factored out f? Well, what f times what gets us back to f? That's 1. So that means if we were to try and distribute it, it would end up back there. Then here you just put r. So f times 1 gives us f. F times -r gives us -rf. So we know we factored it correctly. Now we can get f by itself by simply dividing both sides by 1 minus r. 1 minus r. So this is gone. And then we end up with option B. Once again, this is a very strange way to factor. You wouldn't necessarily think of it too naturally, but it is a good thing to practice multiple times because it will come up on other questions.